I charge my motions, but I didn't charge it.
Okay. So the force that opposes motion of one surface over another is friction. So this only applies to things sliding past each other. Okay? Sliding one surface over another requires enough force to overcome the resistance of friction. And so this resistance comes from tiny little hills and valleys that are on the surface of that object. Little microscopic, you can't even really see them, hills and valleys that are in one surface and the other surface. So when the two surfaces are touching, those hills and valleys kind of lock in place. And so if you want to move that thing, you have to overcome that resistance or those locking in place of those little hills and valleys. So when I want to push and slide this book right now, it's attracted to the tabletop because the tabletop has hills and valleys, the book has hills and valleys, and they kind of lock in like little teeth. So to overcome that, I've got to apply a force to get it moving, okay? And that is a force of friction. So friction has both negative and positive aspects. We talked a little bit about that before. So friction reduces the efficiency of a machine. That's a bad thing. Okay? But without it, you wouldn't be able to walk. That's a good thing. There are two kinds of frictions that we're going to talk about. We're going to talk specifically about kinetic friction today, and then tomorrow we'll finish up with static friction. Okay? So kinetic friction, just like, what does kinetic mean? We talk about kinetic energy. What kind of energy are we talking about? Moving, energy of motion. Okay? Well, kinetic friction is the friction encountered when one surface slides against another. So when I am sliding this book, the friction that is caused from moving one substance against another surface, one surface against another surface, that is kinetic friction. The magnitude of the kinetic friction depends on the normal force. And what is normal force again?
When the two cancel out. No, that's net. Just kidding. I don't know what normal is.
Yeah, okay, you're on the right track. Net force is when the two things cancel out. One of those two things is normal force. The other one is weight. So what is normal force then?
Is it like the force that's left over?
It's not left over. So let me see if I can draw. So if I have an object, where are you? Oh, goodness, I need that day off so bad. Okay, let's try drawing on the right surface. That would help. So if I have an object that's sitting here, force due to weight is acting down. So where's the normal force? Perpendicular to that surface in the opposite direction. Okay? All right, so kinetic friction, the force of kinetic friction depends on the normal force. Okay? Because it's that normal force of the table pushing up and the book pushing down. And you're overcoming that to cause it to move. Remember, in order for an object to move, it has to have a net force that's not zero, right? You have to overcome that zero net force. Otherwise, it's just going to stay right there. So force of kinetic friction depends on the normal force.
Question. So when we're solving equations, are we solving for like the weight force most of the time?
It depends on what the question's asking. You can solve for normal force. You could solve for weight. You could solve for kinetic friction.
And if it's still, does that mean the weight and the normal like cancel each other out or whatever? Okay.
If it's not moving.
It's not moving.
Yeah.
Or not accelerating.
Not accelerating. Right. Okay. So here's a vector diagram of what we're looking at. Let's make sure I did that right. Yes. All right. So here's where we're applying all these forces. Remember, we need to be drawing your free body diagrams. That's going to help you look at what forces are involved in a situation and then how are we going to solve for that. So the figures indicate below, the force of kinetic friction is proportional to the normal force. Okay, so we haven't got to the equation for kinetic friction yet. We're building up to that. Kinetic friction is proportional to the normal force. So if we double the normal force, that means we double the kinetic friction. And that's what this is showing you. And we'll be doing labs with this. I got all my toys in. I got conductivity meters. I've got motion detectors, colorimeters, all kind of cool stuff. Anyway, so just a real simple activity we will be doing with this is you have a spring scale. We saw those yesterday. If I put a certain block on a spring scale and pull it, then I can measure how much force it takes to overcome friction. That would be its force, its kinetic friction force, okay? And that depends on the weight pushing down and the normal force pushing up, okay? So if I were to double that weight, I would double the normal force. You'd also find that you double the force of friction. So this spring scale, there I go again. This spring scale is measuring the force of kinetic friction. And if I double the weight, I double the force on that spring scale, which means I doubled the kinetic friction, which should make sense, right? The heavier the object is, the harder it is going to be to slide it across there because it's got more friction to overcome, okay? So here is our equation for kinetic friction. The force of kinetic friction is equal to mu k, mu, that's just a funny looking Greek M, mu k, a constant, times the normal force. So force of kinetic friction is this lowercase f, force of kinetic friction, and that's equal to a constant, which you will either be given in the problem or you will be asked to solve for, one of the two, and the normal force. Okay, now, they may be really mean in a problem, not really mean, but they may be seen if you understand that normal force, how normal force and weight are related. So in the problem, they may just give you the weight of the object. In which case you would have to say, all right, force due to weight is equal and opposite to the normal force if it's not moving. Okay, so we can plug in there. So I'm just saying there may be some rearranging where you'd have to find normal force first and then plug into this equation to find friction. Okay. All right, so the constant mu k is in the equation is the coefficient of friction. So when we say that, I'm not going to say mu k anymore. I'm going to say coefficient of friction. Okay, so that's what that means, coefficient of friction. The larger the coefficient of friction, the greater the force, frictional force. Okay, and then every object will have a different coefficient of friction. There's a coefficient for kinetic friction, and there's a coefficient for static friction, okay? And like I said, this ought to make sense. Just think about different surfaces. Which would be easier to slide across? Glass or rubber? Glass, of course. Glass is nice and smooth and slick. But rubber or concrete or something like that, rubber is going to be, depending on what kind of rubber it is, it's not going to be very smooth, right? So think about okay, I know they have this there, so that's why I'm using this example. If y'all have ever run at the mini park place in Moulton, I think y'all have run a couple of races there. I don't know its official name, but that little mini park place. It has a little bridge over this little creek thing. What do they put? What's on top of that bridge? It's not straight wood. It has this little black stuff across it, right?
Yeah, it's like shingles on it.
Looks like shingles. Why is that there?
Keep you from slipping.
Keep you from slipping on the wood. Okay, that surface is rough. Okay, and that increases the amount of friction, so you don't slide. So a surface like that would have a really high coefficient of friction, okay? But if it's just compared to, say, if that was metal, a piece of sheet metal there, that would be really slick, especially if it was wet, right? Okay, so that would have a very low coefficient of friction. So every object or every surface has a different coefficient of friction. The higher that number, then the higher the force of friction, okay? And so they're either going to give you what that is in the problem, or it'll be one of the things you need to solve for. Oops, wrong one. All right. Experiments have shown that kinetic friction between two sliding surfaces, you need to make sure you write down these three things. We have two sliding surfaces. These three things are going to be true. It's proportional to the normal force. It's the same regardless of the speed. And it's the same regardless of the area of contact. Those are three important things to remember about friction. So it doesn't matter if I lay my block flat down where I have a lot of the surface in contact, or if I hold it up where there's not as much surface in contact. It's still going to be the same. The frictional force will be the same. It'll be the same whether I slide it quickly or whether I go slow. But it is always going to be proportional to the normal force, okay? Which, remember, is related to the weight of that object, the force due to weight. Okay, everybody got those three down almost? All right, I believe that is it. We will talk about static friction in a minute. Let's see if I can get an example. All right, example 511 is the one we're gonna look at. Example 511. Tomorrow we'll do static friction. So. All right. So 511, someone at the other end of the table asks you to pass the salt. So you slide the salt shaker to that person. The salt shaker has a mass of 50 kilograms and it has an acceleration of 0.787 meters per second square. It comes to rest at the desired location. What is the coefficient of friction between the shaker and the table? Okay, so we're looking for the coefficient of friction. Now, they didn't tell us any forces. So we're going to need to draw our free body diagram, which is what they did here. So you have the salt shaker and the table, okay? The weight, the force due to weight is going to act downward, and the normal force is going to act perpendicular to the surface, which in this case is straight up, okay? We know our acceleration is 0.787 meters per second, and we are looking for the coefficient of friction. So we have to find the force of friction in order to be able to find the coefficient of friction. Okay? So let's look at what is going on. There's no acceleration in the vertical direction. All right, so we are not picking it up, are we? No. All we're doing is sliding it. Okay? So our only acceleration is in the x direction, not the y direction. Okay? So if that's the case, then the weight and the normal force have to cancel out. Okay, so I want to make sure we understand that part right there first. All right, so I'm sliding the salt shaker across the table. I'm not picking it up, right? So if I'm not picking it up, there is no movement in the vertical direction, right? So force due to weight, since I have no movement in the vertical direction, my force due to weight has to equal my normal force. Okay? Because that's going to be the basis for finding everything else. All right? So, if that's the case, then if my force due to weight is mass times gravity, and it's negative since it's acting downward, if force due to weight is equal to the normal force, equal and opposite, then I can just say my normal force is equal to mass times gravity. Everybody see where I got that from? Okay. All right, and then my acceleration is 0.787. Okay. We know from Newton's second law that the force of kinetic friction is equal to mass times acceleration because all forces are mass times acceleration. So we can say that the force of kinetic friction, since this thing is moving, force of kinetic friction is equal to its mass times its acceleration. We also know this formula for kinetic friction, right? So we know two formulas for kinetic friction: mass times acceleration and coefficient of friction times the normal force. We good there? I'm going to give it a minute to soak in. I know there's two equations for kinetic friction. Kinetic friction is the coefficient of friction times the normal force. It's also mass times acceleration.
What's mass times acceleration?
Any force.
Oh, so you can. Does it
Pretty much.
depend on which variables you have, which one you use? Okay.
Yep. So what I'm going to wind up doing is I'm going to wind up setting these two things equal to each other. Okay? And remember that my normal force is also equal to mass times gravity. Okay? So we know weight is negative mass times gravity. It's the opposite, it's acting downward. So my normal force is also mass times gravity. My coefficient of my force due to friction is coefficient of friction times the normal force. And it is also mass times acceleration because any force is just mass times acceleration. Okay, so I'm going to wind up rearranging those and putting them together to solve for what I need. What is it I'm looking for? So we got to keep that in our mind. What is it I'm trying to find in this problem? Trying to find this thing right here. Okay, that's what I'm trying to find. Okay. Don't know why that does that sometimes. Fiddlesticks. All right. Okay, so okay, you can't see this very well, so I'm going to talk through it up here. So we're going to take those four equations and we're going to rearrange them to solve for the coefficient of friction. All right. So here were our equations. Force equals mass times gravity. Normal force is equal to positive mass times gravity. Force of friction is equal to the coefficient of friction times the normal force. And that's also equal to mass times acceleration. Okay? And this is what I'm looking for. Okay? So what I wind up doing is I'm going to solve this. This is what I'm looking for. So how do I solve that equation for the coefficient of friction? I divide by the normal force. So my coefficient of friction is equal to the normal force divided by the force of kinetic friction.
Is it flipped?
Yes, it is. Thank you. Okay, so now what I'm going to do is I'm going to wind up plugging in for each of those. So force of kinetic friction is mass times acceleration, right? And we have a mass and we have an acceleration, correct? In the problem. What is normal force? Mass times the force of gravity, right? Can I simplify this down even anymore before I start plugging in numbers? How can I simplify that down even more? You can cancel out the ends because it's the same mass, right? The mass, the salt shaker didn't change. Okay. So the coefficient of friction in this case is equal to the acceleration divided by gravity. So 0.787 divided by 9.8 meters per second squared. It's a constant number, so we don't have any units involved with it. So my units should cancel out, and that's my answer. 0.787 divided by 9.8 gives me 0.0802. Okay. But the main thing to understand is that you can get normal force if you know weight. Okay. And then, I mean, if you don't want to do this whole ratio thing, you could actually, let's see if we could do it a different way. I could just set these two things equal to each other and get exactly the same results. Because my normal force is mass times gravity. I'm solving for that. Same exact thing. Okay. So whichever way you want to do it. Now, you can't just plug directly in here because guess what? We don't know what frictional force is, right? So that's why we have to use a combination of both of these because they didn't tell us what frictional force is. So we really don't have a way. We don't have a way to find frictional force before.
So is the force by weight the one that's negative?
I guess we could find it here. Yeah, we could do that. We could do mass times acceleration here, plug it in there. We can find mass times acceleration here, plug it in here, and then find UK. But so I'm sorry, I interrupted you.
Oh, no,
What
it's fine. I interrupted you. You're the teacher. I mean,
you were saying is what?
is the, or I guess that was the normal force. It's
Mhm.
positive because it's like
Because it's
perpendicular or whatever.
it's going up.
Is the weight normally going to be negative?
Weight's all because force due to gravity is always what? It's holding you
Down.
down.
Okay.
Okay, so your weight's always going to be going down, and your normal force is always going in the opposite direction.
That makes sense. I guess it was just counterintuitive to me because the force is like the weight force is like the normal one. Well, no, it's not normal. But what?
No.
You know what I mean? The typical one, the one that you find.
Okay,
Sure.
we got to use our words differently now. Normal is not the normal that we normally think normal is, right? Okay. All right, so there is our example for kinetic friction. So homework tonight is 31 and 32, 35 and 39 and 40. 35 is more of a conceptual word type answer. The rest of them are problems to work out. So, and goodness, these are only 5 problems. So you should be able to get those done before we leave out of here. Because we leave out of here, what, 8? What time do we? 8:55? 8:50. So you'll get most of them done anyway. So, any questions? Any questions?
Not at the moment.
Okay. Well, if there are, let me know.